Hi, this lesson is meant to replace being in class so we can talk about Chapter 3, Lesson 1, Determinant of a Matrix. We're going to start off with some basics. What you should know, first of all, is that the determinant of a matrix, especially when it's a 2 by 2 matrix, is just AD minus BC. Remember that A, B, C, D are the entries of this matrix. So 3 times 5 minus 6 times 2, or 15 minus 12 is 3. In a matrix like this, 8 times negative 5 is negative 40, minus b times c, which is negative 2 times positive 3. So basically add 6 to that, and the determinant of that matrix would be negative 34. One more example for review. 8 times 3 is 24, minus 4 times 6, which is 24. So in this case, the determinant is 0. If you were to look at this kind of a matrix, and remember what we were talking about, this matrix would have no inverse. Today, though, what I'd like you to really understand a little bit better is this idea of a minor and a cofactor. The reason that you'll be doing that is because you're going to be finding the determinants of larger matrices like a 3 by 3 or a 4 by 4. Let's just take a peek at what's going on with this. In this, I have a 3 by 3 matrix, and the first thing that I'd like you to be able to understand is just this formula, that there's this alternating based off of the entry, the rows and the columns, and then the determinant of the minor of that area. Some of those terms are a little bit unclear, so I'll explain it a little bit. In order to find all of the minors of this matrix, I'm going to basically have 9 entries, just like I would have from the original matrix. If I'm focusing on just the 3 that's here, in order to find the minor for that, what I do is I take the minor, the determinant, basically ignoring the rows and the columns. As it says here, deleting the ith row and the jth column of what's going on there. So negative 2 times negative 9, negative or positive 18 minus 28. Once again, positive 18 minus 28 is negative 10. Then I move to the next entry. So in this case, once again, what I'm looking at is this negative 5. Ignoring this row and this column, I really have just these 4 entries, 6, 4, 0, and negative 9, and do it's kind of like the mini determinant, the minor of that. 6 times negative 9 is negative 54, minus 4 is negative 58. So once again, negative 58 is the minor from that. I'll do one more time to just show it to you a little bit slower. Now I'm focusing on this, ignoring the top row and the farthest right column. 42 minus 0, once again, would be 42. This 6 right here, ignore this row and this column. Positive 45 minus 7. Negative 9 times negative 5 is positive 45 minus 7. 45 minus 7 is what? 38. This, ignore this row, this column. Negative 54 minus 0. This entry, ignore this row and this column. 42 minus 0. Going down to this 0, ignore this row and this column. Negative 20 plus 2. Negative 20 minus a negative 2. Negative 20 plus 2 is negative 18. 7 that I have right here, ignore this row and this column. This row and this column is 12 minus 6. 12 minus 6. And then this row and this column, ignore them completely, would be what? Negative 6 plus 30, 24. Now all we did so far is this portion. We found the m. In order to find the cofactors, what I need to be able to do after finding the determinant of all of those minors is I need to figure out, based off of where they are, whether or not they can stay where they are, or I have to change them. So for example, this entry right here is in the first row and first column. If I take 1 plus 1, because it's 1 row, 1 column, I'd raise negative 1 to the second power, and this entry would stay the same. I think you can figure out where the pattern is going, that basically every other entry is going to change. So this negative 58 will change to a positive 58 because the rows and the columns for that entry basically add up to an odd number. This will stay positive 42. This will change to negative 38, stay negative 54, change to negative 42, stay negative 18, change to negative 6, stay positive 24. And I'm just going to highlight those values once again, that these are the values that changed their symbols to the opposite based off of the idea that the rows plus the columns for those entries are an odd number, so those need to change. If you're going back to say, what did I just do? You just found the cofactors of all of the entries into it. If you're wondering, why would we do this? I'll explain this in the next video, that you can use those cofactors to find a determinant very, very quickly. That'll continue on the next video.